In this lesson, we're going to be solving rational equations. And there's kind of a process to it. This is the first part. We're going to do about 5 problems in this one, and then we'll do about 4 problems in the second part, and they'll be a little bit more complicated in the second. But here's the process that there's a lot of different ways to do it, but this is one of the processes that you can do to solve these types of equations. First is we're going to need to create some common denominators. All right, act as if you're going to be adding and subtracting these equations together. And we're not, but we're going to pretend like we are. That's going to get us a common denominator. We're going to set our numerators equal, aka we're going to drop our denominators once they match. We're going to solve each problem, and then we're going to check for extraneous solutions. Because we're manipulating the look of the equation, which means we may be creating solutions that don't actually end up working. So, well, let's begin. So the first one we'll have is x over 3 plus 2 equals 5 over 6. And there's a bunch of different ways to solve it, but this is just one idea of how you can go about solving it. So we're going to go through this. We're going to find a common denominator. So right now we have a 3 and a 6, but technically this has a fraction as well. So we'll make this an over 1. So what can they all become? Well, they can all become 6. So we're going to multiply the pieces that it takes to make every single one of our denominators 6. So this is going to be something over 6 plus something else over 6 equals something else over 6. So we got to figure out what it takes for that to happen. So on this fraction, we're going to multiply top and bottom by 2. On this, we're going to multiply top and bottom by 6. And this, we don't have to multiply by anything. So we'll have a 2x plus 12 equals 5. All right, so now to solve this, once we have our denominators that are equal, we're going to set the numerators now equal to each other. So really what's going to happen is we're going to drop our denominators. We're not focused on the denominators equaling each other anymore, we're focused on the numerators equaling each other. That really means that we need 2x plus 12 needs to equal 5. All right, so we solve that. So we will subtract 12 over. All right, so that'll get us a 2x equals negative 7. And we'll divide both sides by 2. And that will get us an x. Actually, it should be, we're dividing by 2. And that will give us an x equals a negative 7 halves. All right, and then we can plug that back in to make sure that it works. So, next problem is 2 over x minus 7 over 3 is going to equal negative 29 over 15. All right, we need common denominators on everything, so we could make every one of these have a 15 on it. So this value would need nothing multiplied it, but this would need a 5. This would need a 15 multiplied to it. But they all also would need an x attached to it. So this would not only need a 5, but need a 5x. This would need an x multiplied to everything. All right, so when we do that, that's going to get us a 30 over 15x minus 35x over 15x equals a negative 29x over 15x. Once we have all of our common denominators, we can ignore the denominators and just focus on the numerators equaling each other because we already have the denominators equal. So now we're trying to get 30 minus 35x equals negative 29x, and we will solve. So to solve, let's add 35x over to the other side. So that gets us a 30 equals 35 minus a 29 will give us a 6x. Divide both sides by 6. And x would equal 5. All right. Now, what we didn't talk about on that last problem is what x cannot equal. So that's really something that we're going to try and do at the very beginning of every single one of our problems, is what can x not equal? Because here we didn't have a variable in the denominator, here we do. So here we didn't have any domain issues, this one we do. X cannot equal 0. So if we solved this whole problem and we got a 0 as a solution, we'd actually have to kick it out. Because we've taken a problem that was a fraction and we manipulated it into where it wasn't a fraction, and that doesn't have a domain issue, but the original problem does. So we'll have to keep that in the back of our mind, and we'll actually start with that on the next one. All right, so let's look at the next. So if you have 4 over 5x equals a negative 1 over x plus 1. All right, so here, to keep in the back of our mind, what can x not equal? 0 would cause a problem on this one. So x cannot equal 0, and negative 1 would cause a problem on that. So once we solve this, we have to make sure that we don't get a 0 and a negative 1 for our solution. Now this one is going to be a little bit different. We can treat this one, and this is just purely a recognition thing, that we don't have all these multiple pieces added together. So we don't have multiple fractions on one side. We actually have a proportion. And we can solve proportions different than when we solve these. And you could do the same thing down here, but once you have a proportion, usually one of the more efficient methods of solving is to cross multiply. So, and I'm going to make sure that that negative 1 applies with the numerator. You could apply it to the denominator, but I'm going to apply it to the numerator. So this cross product is going to be a negative 1 times 5x. This cross product, I've already done the negative, so that's going to be a 4 times x plus 1. And I can go about solving that. So, to solve that, I have a negative 5x equals, I'll distribute that in, so 4x plus 4. All right, and then here I would bring the 4x over. So I would subtract 4x. All right, so that's going to get us a negative 9x equals 4. We'll divide both sides by negative 9. And that gets us an x equals negative 4/9. Now it's not a nice answer, but it's not one of our domain issues. It's not a constraint. So it should work when we plug it back in to make sure that actually that fraction does equal that fraction when you plug it in. All right, let's do another. So if we have 3 over 4x plus 5 over 6x equals negative 19 over 12. All right, we need to get a common denominator. We can't cross multiply because we don't just have a proportion equals, or a fraction equals a fraction. So we don't have a proportion. So we have to go back to, let's get our common denominators, and then we can drop our denominators. So what can they all become? As far as the numbers, a 4, 6, and a 12, they can all become 12. So I'll have to multiply this by 3, I'll have to multiply this by 2, and I won't have to multiply that by anything. They also all need an x. So this needs an x. So I'll multiply this by x. Alright, so that's what I need to multiply every piece by. Okay, so this is going to become 9 over 12x plus 10 over 12x equals negative 19x over 12x. Great. Once we get common denominators, we can drop our denominators and just focus on our numerators. So 9 plus 10 equals negative 19x, and we solve. We combine those two. They don't have variables, so they're already like terms. So we have 19 equals negative 19x. Divide both sides by the negative 19, and x will equal a negative 1. All right. Now at the very beginning, I should have talked about our constraints. The only x that would make the denominator 0 would have been 0. So x could not equal 0 on that. And we got a negative 1, so we're good. All right, so let's do one more. All right, number 5. So 6 over 3z plus 4 equals 4 over 2z minus 5. All right, so at the very beginning I need to talk about what x cannot equal. And if I don't quite see it, then I just need to take and do a little bit extra math on this. I need to take the 3z plus 4 and I need to set it equal to 0. And then whatever value makes it 0, I'm just going to kick it out. So on this one, I'll subtract 4. 3z equals negative 4, divide by 3. Z equals negative 4/3. So that's one value that I have to kick out. And then I would do the exact same thing for this one, where I would add 5 and divide by 2, so it ends up being a positive 5/2 that I end up having to kick out. So those are my two exclusions. So let's figure out if we need to do a common denominator or we actually have a proportion, so we could just cross multiply. So we have one cross product is 6 times 2z minus 5, and then that's going to equal the other cross product of 4 times 3z plus 4, and we'll distribute. So that will get us a 12z minus 30 equals 12z plus 16. Let's start rearranging stuff. So let's bring our z's, our variables, over to the left. We'll subtract 12z. And at the same time, I'll bring anything without a variable to the right. Okay, so if I do that, I'll get, those will cancel. My variables actually cancel. And we have 0 equals 46. Now we lost our variable. That actually means, and we have a 0 doesn't equal the same thing, like these don't match perfectly on the same side. So that means we have a no solution. There is nothing that we could plug into this fraction to make it equal each other. So that's our answer for that one. All right, and that was solving rational equations part 1. And we'll do another video that involves a little bit more complicated problems in part 2.